Okay, so we're the senior design team from USC Columbia that's going to be handling y'all's DEF storage, transportation, and monitoring system. If you want to hit the next slide for me. So Nathan Jones is our industry sponsor, and our faculty sponsor is Sang-Hee Wan. And these are our team members, as we were introduced earlier. So y'all's scope, as given to us, is listed at the bottom, where y'all needed to transfer DEF to a primary storage tank, transport the DEF to multiple day tanks connected to the test stands on the second floor of the R&D building. And the DEF needed to be, the level of the DEF needed to be monitored in this storage tank in the basement. Want to hit the next button for me? So just to go over what we're going to be talking about today, we're going to talk about the needs that we identified, the specifications we're going to use to measure these needs, the functional decomposition of the system that we want to create, the concepts that we came up with, and our top choice of concept. So this is our master list of needs, and it was based on our initial visit with MTU back in October, a couple conversations with Nathan Jones, and talking with the operators of the test stands in the R&D building. If you hit next for me. So from this master list of needs, we need to narrow this down to our priority needs, or from our quality needs to our, what do you call this? To our critical needs. So we took our master list of needs, and each team member was given 10 votes to give to the needs that they thought of as our critical needs. And this narrowed us down to our next slide, to our critical needs of about 9. And from there, we needed to get to our umbrella needs, our 3 needs that were really going to drive our system. So again, we voted on what we would count as our umbrella needs. We were each given 5 votes, and this led us to rank it, and we went to our mission statement. It got us to this, the 3 needs that we identified as our umbrella needs that were going to drive our system, right? So the new system that we're going to design needs to reduce the risks of the current system, needs to monitor the fluid levels in this bulk storage tank, and it needs to be easily maintained. And that drives our mission statement that MTU needs a diesel exhaust fluid storage and transportation system that reduces risks, monitored fluid levels, and is easily maintained.
All right, so next we had to associate our needs with appropriate metrics. And establishing these metrics helped us to better understand the numerical requirements for the customer needs. And as you can see, the majority of the metrics are associated with units. So what our team did was first rank the customer requirements based on importance, 5 being most important. And this array of number here, we assigned numerical integers that showed how the engineering characteristics contributed to the customer requirements. We then multiplied the ranking with the numerical values across and summed them up by column to achieve individual raw scores, and compared that with the total raw score to get relative weights. And by observation of the relative weights, we were able to rank the engineering characteristics based on importance. Next. We then had to establish target specifications for the customer requirements. These are a range of values based primarily on interviews with MTU, as well as statistical averages, engineering standards, and the current system that's in place. So all these target values are not likely to be met. That's why our team developed minimum values or fallback values. This provides flexibility in our design while still ensuring that our product is successful and meets requirements. So for example, to store enough DEF for X amount of time, our minimum value was 3,000 gallons, and we got that from the approximate value that MTU currently receives in DEF fluid per shipment. However, our team would like to increase that to store 5,000 gallons, and that's our target value. Alright, so far we've established what our product needs to do. Next, we had to determine how the product was going to be successful, and that's where functional decomposition comes into play. So here's a simple functional decomposition diagram. It shows our 2 inputs, DEF and energy, and our 3 outputs, DEF, signal, and energy. Here is a sequential functional decomposition diagram. This provides a more detailed flow of our known materials, energy, and information of the system. So for example, one of our inputs, DEF, goes into the system accepts the fluid, stores the fluid, transfers the fluid to the day tank, and then outputs DEF to the engines. And here's our concept combination table. It shows 6 of our functional elements that play an important role in how our product will be successful. Within each element are different approaches to a solution. So in generating concepts, we took a single approach from each element and then combined them to form a single design. And on the next slide, we'll take a look at our first conceptual design.
All right, so from the concept diagram, we took the functions, each of the functions, and gave them a specific way to complete the function. And in this first concept, we devised the differential pressure bulk tank. In this tank, the fluid is delivered via tractor-trailer tank and pumped directly into a bulk tank in the basement of the R&D building. And in this bulk tank, the levels are measured using a differential pressure sensor that measures the differential pressure of the head pressure from the level of the fluid in the tank and compares that to the atmospheric pressure, and that will allow you to know what level is inside of the tank. When the level of fluid gets low in the bulk tank, then a centrifugal pump will be used. A centrifugal pump will be used to send the fluid from the basement to the second story of the R&D building. A few pros or benefits to using this bulk tank are that it requires less manpower than the current system, and that it will also be more cost efficient to buy this fluid in bulk as compared to buying them in carboys as they currently are purchased. And an external centrifugal pump will also be easy to maintain because the pump will be on the outside as compared to some of these other concepts. But some of the drawbacks of this concept are that it will be a big tank, so it will probably have to be assembled in the basement, and piping will have to be laid out so that fluid can be transferred from the basement to the second story. In this second concept, we have a similar idea. The fluid will be delivered on the using the tractor-trailer tank and directly fed into the basement into this second bulk tank. But instead, in this ultrasonic sensor bulk tank, the fluid level will be measured using an ultrasonic sensor that will be placed at the top of the tank, aiming down, as you can see in this image here. And the fluid will be sent to the second story of the R&D building using a submerged pump, which will be internally, it will be on the inside of the actual tank itself. Some pros, like the other tank, it requires less manpower and can reduce the cost. And also, ultrasonic sensors are already in use in the day tank, so it would be easy to integrate into the current PLC system. Some drawbacks, again, this tank is kind of big, so it may need to be assembled in the basement, and the piping will also have to be laid out for this tank. But also with this different submerged pump, it may be a little harder to perform maintenance on the pump because it will be inside of the tank itself. And I will pass it to my colleague for the next.
So the next concept we'll discuss is known as the tractor-trailer storage tank. This idea will utilize instead of having a bulk tank installed within the R&D building, we will solely use the actual storage tank that's delivered by the supplier and just park it outside of the building, having a differential pressure sensor to monitor the levels of the tank, and using a centrifugal pump to pump the fluid into the R&D building. Some pros to this is that it will reduce the manpower needed on MTU side, as only the supplier's driver will drive up, park the trailer, and leave it out there and hook up to the hose connection. It's cost effective compared to buying sole carboids, and there's no need to install or buy this large bulk tank that would need to be assembled on site. Some cons to this is that pipes will have to be installed both on the inside of the building, leading from the second floor down to the first floor, and on the exterior of the building to connect to the trailer tank. And that the day tanks will have to be used as backups during tank changes. Considerations for this concept will be where the tank trailer will be parked, where it will be located in general, as there is no current space currently built near the R&D building. insurance and supplier pricing for keeping the tank on the campus, and where the built-in fuel monitoring system that is installed in the tank could be integrated with MTU's monitoring system. The next concept involves just a reduction of risk. This will employ the use of the cardboard still being delivered from the bulk's chemical storage room from the MTU campus, but rather than using a forklift to lift it up to the second floor, a outdoor elevator will be used to lift up the cardboards and be jacked onto the second floor using the pallet jack. This concept will reduce risk as the lifting of the cardboard will be removed from the current process. However, it does not reduce the manpower needed to transport the cardboards, and it's the load cells used to measure the fluid level in the cardboards are quite expensive. The next cell, however, reduces this risk even more by utilizing the crane currently installed in the first floor of the R&D building. This will allow the cardboards to be stored in the basement rather than on the second floor, using the hatch currently found on the floor of the first floor of the R&D building. Load cell will be used again to monitor the fluid levels, and a double diaphragm pump will be used to pump up the fluid to the second floor. The cons of this would be where you still haven't reduced the manpower involved, moving the cardboards from the bulk chemical storage plant all the way to the R&D building. The load cells are once again pretty expensive, and that piping will need to be installed from the basement up to the second floor.
After the concepts were generated, we went through a rating and ranking process to determine which one we felt was the most viable option. This table here, we came up with selection criteria based off the customer needs, and we compared each concept we came up with the current system on a plus, minus, and zero basis based off of whether or not we felt it improved the MTU's ability to achieve the selection criteria's needs. And this process voted out, as you can see, the two least desirable solutions, which was the elevator and the crane, and led to the next voting process, which is in the next slide. Actually, we had to do the cross comparison first to come up with the criteria weights, as you can see on the far side there. It's a cross comparison of each of the customer selection criterias, and just a quick explanation: 1, 3, 5, or 7 depends on which ones we felt were more important. So across the top, reduce risks is more important than easily maintain, and we gave that a 5 because we felt it was a good bit more important. And so you can see that these are just the reciprocals of that, and then we took the averages of the normalized table to come up with criteria weights to rank the importance of the selection criteria. And this is the final voting process, which took the weight of each selection criteria into consideration compared to a rating, which we scored on a 1 to 5 basis based on how well we thought it achieved the needs in the selection criteria. All of these processes were all done collectively by the team. And we came up with a new concept by combining the two lesser ranked concepts in the previous table. This one also incorporates the tractor trailer tank delivery and into a bulk tank in the basement. And this is direct fed, and it's done with an ultrasonic sensor and a centrifugal pump, which are the two most desirable parts or components of the two concepts we combined to make this one. Some of the pros are it has a more desirable level sensing method because ultrasonic sensors are already used in the day tanks, and it's less expensive to buy DEF in bulk. Some of the cons, again, that you're going to have to run piping through the floor of the R&D building. And we chose our top concept, which is in the next slide, actually to be this newly generated concept. We felt that it incorporated all of the needs and met them very well, We also felt that based off the project scope, the basement storage location was most desired by MTU. And based off of talks with MTU, we learned that ultrasonic sensors would be a good choice to continue using within the system. And also there's a possibility of using the current pump to become more cost efficient if we can. Any questions?